All right, today, here's the idea of what I want to cover today. I want to talk about how the law of sine and the law of cosine, how the first one was originally created, and then eventually, like tomorrow and Wednesday, we'll start getting into where did the other one come from. So here we go. Law of sine today. So section 6.1. 6.1. I know that seems a little weird. We were in chapter 5. We did 5.1, 5.2, 5.3, and then suddenly we magically jumped to chapter 6 on Friday, because these are the last sections about trig functions that I want to cover. So we're dealing with the law of sine of these first ones. The goal today is how do they derive it? Where does it come from? So I'm just going to show you the easy way of how they came up with it. So we're going to derive it. And then the goal today is to do an example of how it works and how to use it. And hopefully, once we go through this example, we'll talk about whether it has one solution or many.
So when is our test going to be?
Next week.
Tomorrow.
I'm thinking as early as possibly Tuesday or Wednesday next week, but that's the earliest. It'll be probably pushed back because we still have a couple days of notes here, and I want to make sure that we have them all covered and we know what we're doing. So, all right. Versus.
How can we be not on this like a bubble?
Hey.
Larson chews on his water bottle like a dog.
All right, today let's talk about the law of sine. Shh. Okay. All right, here we go. All right. So on my right triangle here, and I'd like you to draw this in your notes somewhere. Make a right triangle. We can call it anything you want. Let's call it ABC. And it really doesn't matter. As long as you have a triangle, it really doesn't even matter if that's a right angle. In fact, I'm not even going to put a right angle. Come on. Let's just do let's just make it a random triangle. Because again, the reason why I really like the law of sine is that for these types of triangles, these can be what we call oblique triangles. And what an oblique triangle is a triangle that doesn't have a 90-degree angle in it. They can be obtuse, they can be acute. They don't have to be right triangles. Could be equilateral, that's considered oblique, where it's not a right. That's the idea is that the walls can be random. Alright, so if this is my triangle, how they derive the formula for the law of sine. If you don't know what the law of sine is, it's on your property sheet. This is what we had written down the other day. Sine of angle A over little a is equal to sine of angle B over little b equals sine of angle C over little c. I want to show you how they came up with this. And this is the formula that you should have on your property sheet already. I know they may not use A, B's, and C's. They have like lambdas and alphas and thetas in there. Betas. Yeah. Okay. But I want to make sure that you understand how to use the formula today. All right. So here's how they came up with it. They drew a altitude in here. An altitude is a line that goes from like the tallest point straight down. So it makes actually two right triangles in there. What this is the actual height of an object. It's called an altitude. It's how you find the height of an object. And what they do is they showed how the law of sine comes about by finding area of triangles. Now, if you don't know how to find an area of a triangle, like let's say we're finding the area of the large triangle. So we're going to find the area of ABC. Triangle ABC. Now, how it works, if you want to find area of something, you take half the base times the height. That's just how you find it. That's how you do it in geometry class. That's how you do it in junior high days. You take base times height, cut it in half. That's a triangle because it's half of the square, that type of thing, or a rectangle, or a parallelogram, that type of thing. Now, how this formula actually applies to that is this is how it works. They pick one of the angles, so they're going to pick angle A. So they pick this angle right here. Okay, so they pick angle A, and what they do is to find height from angle A, and they put height, that's my H here, in terms of angle A. They use the sine of angle A. So sine of angle A is the opposite wall, which is the height, over, so this is the opposite wall to angle A, that's the opposite, so that's the height, over its hypotenuse, which is this wall. This is the hypotenuse.
Height?
The hypotenuse,
Oh,
the
sorry.
height, okay? And that wall is little c. That's the wall. Now, why I know it's a little
Because
c?
it's opposite C.
It's across from angle C. This wall is little b. It's across from big B. This is little a over here because it's across from little a. But again, that's where the little lowercase letters come from. Now, how they're actually doing it? Sine of A is the h, which is the height, over its hypotenuse, which is letter c. And then what they do is to find height by itself, they just multiply the c across. So this part right here, c times the sine of angle A, that part goes here, in this spot. So it's half the base, which our base on this picture is little b, that's why I picked this picture. So that's the whole base, so half the base times the height, and the height is c times sine of angle A. Does that make sense, like how they found the area of that triangle? It's half the base, which is little b, times c times sine of A. Because again, why we're doing this part, that's the height. That's this part if I just rearrange for h. Now, you're probably thinking, okay, Ward,
No, he's learning.
okay, Ward, why did we pick that? This formula is how they get eventually to that one over there. They show how to manipulate it and to actually simplify stuff. Okay, so let's do the second one now. Okay, to do the second one, to show you how I'm going to use this. In fact, I'm going to circle this. If you don't have this written on your paper, you probably should. It's how you find height of an object, or how to find area of it. I'm gonna do it for over here as well. So if I picked a different angle, let's say I picked angle C instead, not angle A, to figure it out. You'd have to do, the height times the base cut in half. But if you pick angle C instead, sine of angle C, it's the height over its opposite wall, which this wall is little a. You'd multiply the a across, which is a times the sine of angle C equals the height. And that's the spot that I would plug in here instead. So if I didn't pick angle A, I picked C, that's what I put in for H. So it's half the base times the height, which is this part. And why I'm putting this down, I'm going to circle this one as well. That thing that I have circled and this thing are actually equal to each other. It's still the area of the triangle, even though, do you notice that they're using different letters?
Yes. One's a long, one's the angle.
Okay, so again, what I'm doing here is I'm finding the area of the triangle and I'm going to show you how they came up with the sine formula. And so what I'm doing is I'm taking half the base times the height and I'm putting height in terms of sine, which is this and the sine is that. So that's why I'm putting the height in there. So I'm replacing h with those two parts, one at a time, so you can see my two formulas. What I'm going to do is I'm going to take those two circled parts and set them equal to show you what the formula is. But does everyone have that kind of written down, the idea of the height? Okay, let me write those two down so I can actually show you. That part right there is 1/2 b times c times sine of A. And the other one, which is this one, is 1/2 b times A times sine of C. Alright, so that's this part I have written down there. I put it over there. I put that one circle over there. They're actually equal. It's just the area of the triangle. So I just wrote it two different ways. And how they came up with the formula that's up above, and it doesn't matter which one I have. Did everyone have that kind of written down though?
Yep.
Okay, so that's what I have over there. I'm going to show you how they came up with the actual sine formula, the law of sine. Does anyone still need it?
Nope.
Mace, you good?
When was the law of sine discovered or made or found?
I don't know the history of that one. So,
Can I Google it?
Okay, we're good though? Josh, you good?
Yeah, that's a yes.
Alright, here we go. Okay, to show you how they came up with that formula up above, all they did is they noticed that both sides had something in common. That they both had little lowercase letters out front, they both had halves. So here's how you come up with this formula up here, or like portions of it. They divided both sides by the same terms. And the terms they chose is they chose to divide by half, because again, if you divide both sides, that's a property of equality, it still balances the equation. So they divided by half. They divided by A, B, and C. They divided by every lowercase letter. The reason why I'm allowed to do that, as long as I do it to both sides, it still balances the equation. The numbers would still be the same. So they're going to divide both sides by half, A, a B, and a C.
They're all going to be.
And so what happens when you actually divide by this, certain letters cancel out. So like for instance, for the numbers, the halves are gone. On this one, the B's are gone and the C's are gone. And over here, the B's and the A's are gone. And what you're left with is the law of sine.
Sine
I don't
A.
even know what the law of sine is.
Well, you're looking at right here.
That is the law of sine.
It's a proportion of where it's a wall
I'm going to have the B in there.
and its angle across from it. So when you're looking at a picture like this, what the law of sine actually stands for is that when you have a triangle, like such, let me get rid of all these markers that are in here.
Nice job.
Okay. When you have a triangle, you have its angle and its opposite wall. That's all you need for the law of sine. You need an angle and an opposite wall, but you have to take the sine of it. And then if you pick another wall and an angle, you use those. So sine of C and over little c. Again, you can pick any of these formulas to choose. Now I just showed you how they set it up, and then we can do it for the other one as well. We can do it for sine of B. It's been the same idea. But that's how they actually developed it. That's how it's derived. The goal today is to do a couple examples of how to use it, and to show you that one example we started Friday where it had two potential answers. And why does that problem have two answers? We'll try to explain today. I'll try to show you like a visual aid of why it works. Okay? What? Eventually, yeah.
Wait, but I'm...
Maybe Wednesday this week.
Are we testing on Wednesday?
Maybe Wednesday.
Maybe Thursday?
Maybe. All right. Hey, let's do an example. I want to kind of go through kind of an easy-based problem to kind of show you how this works. So let's say we're given a problem where I have angle A is let's say it's 25 degrees. The opposite wall is say 50
degrees.
50 feet. Let's go with
37 degrees.
37 degrees.
Wait, can't we?
And
100 feet.
I want this wall right here.
74.
Maybe that's what the question asked for. Where, and what the homework would actually look like eventually, this is what they would have. So maybe this is question number 1 in your homework. And it would say, angle A is 25, angle C is 37, little a is 50 feet, find little c. And maybe that's all the question asked for. So you'd have to draw your triangle, and again, I don't know what type of triangle it is. Now, when you look at this picture, why I know this problem has one solution. When you look at the acronym, we have 4 acronyms that are set in geometry class. The 4 acronym systems are these: SSS, SAS, ASA, and angle, side. So this last one is basically just a different form of angle, side, angle.
Isn't there another?
No. Now, these are the 4 that you have that have one set solution, like I have here. That I'm given an angle, and a side, so that's this bottom one. And again, why I said it's just a different version of this one is because technically you do have all 3 angles of that triangle already given to you. Because triangles have to add 380. So if this is 62, then the last angle here would have to be like a 118 or something like that. I don't even know if that's right. I'm not doing my math right. I don't think it's got to be maybe a 128. Hold on. See, 180 minus 37 minus 20.
118, you did right.
118. Okay.
You are a genius.
All right. But anyway,
MrWorkNow.com.
all right, stop. All right. So when you have 2 angles of a triangle, you can automatically find the third. So technically, I'm actually doing this one as well because I do have 2 angles and the wall, or 2 angles and a wall in between. So it could be angle, side, angle. That's the setup. When I first start the problem, I can put my little S's and A's. A's are for angles, S's are for sides. And when I plug those in the triangle when I have my numbers set, it kind of tells me what type of triangle I have. And if it's one of these 4 acronyms, it has one set solution to it. Like it's one set triangle, there's no other options. But when it's the inappropriate one, which is this one down here, sine, sine, angle, when it's that one, that triangle potentially has two different triangles in it.
Isn't that backwards?
Now here's the reason being, and this is the definitive way. When they just give you an angle to start with, and they give you a side, and they give you another side, okay?
It's a bunch of.
That second wall here, this wall, since they only gave me an angle, this thing could be any length I need to connect to it. The problem is I could lean this wall in closer, so it could be in here. Jeez, that's a terrible wall. I could. That's a terrible wall. I could lean this side in closer,
Make a right angle.
and maybe this wall is the same length, so it's like swinging a pendulum. It can come in closer, or if I swing it out further so it goes this direction, it could connect right here. And so the idea is that this side would actually, if I move it to do two different locations, it actually produces way different types of triangles. Like this first triangle is really small.
It's like planetary motion.
That looks like a piece of pizza.
So yeah, it looks like a slice of pizza, but the angle right here is really obtuse. It's really a big angle. When you go to the other triangle, it's a lot larger type of triangle. Like the area, anyways, is really big. But the idea is that this angle on the top is really acute. It's smaller than 90. So
Big piece of pizza.
hopefully that picture kind of explains why the inappropriate one can have two different solutions. The other ones can't, because you can't move the walls or angles around to until it locks it to a grid. That's why in geometry class we really focus so much on these little acronym systems, because these are the four that we have that definitively prove that you have equal triangles. That there's no other way to draw it. That the triangles have to be the same. This one is open-ended. That's why we never really called it the SSA theorem. We had HL theorem. That was the one that Holden brought up last time, because those only worked on right triangles. I didn't guarantee that this triangle had to be right. In fact, we found out it was obtuse. It was 118.
That is crazy.
So
It is oblique.
yeah, it's oblique. So we're trying to show how to do this. Okay, now the goal is to show you how to work with this problem and then do that problem we did Friday. And then that's where I want to stop today. I'm going to go through this pretty quick. I just want to show you how to find little c. So when you set this up, so this is the problem they give you. Here's how I would attempt this problem. Sine of angle A, so sine of 25, over its opposite wall.
A.
Okay, sine of angle C, over its opposite wall, and that's how you solve it. So just a proportion. You cross, multiply, and divide. So I'm going to start here. I would again, I always start with the number above or below my variable.
Fish.
You cross, multiply, and divide. Yeah, it looks like a goldfish. That's what I always call it.
Equal.
So 50 times the sine of
That's a
37.
cute little fish. Is that a shark bait?
Yep. And then you divide by sine of 25.
We use the fish.
And that's how you'd actually get my answer. Now, if I'm actually typing this in, I have to use a lot of parentheses. Hold on. 50 sine 37. You get 30 point something on the top, then you divide that by the sine of 25 on the bottom, and we get 71.2. 71.2. And again, the book will probably ask for 1 or 2 decimal places. That's the answer. So the wall here is 71. Now, let's talk about this. Why does that make sense?
Why couldn't you use the B one?
Wait a minute.
What?
If we don't have a wall.
Yeah, we didn't have B. It didn't ask for B, it asked for C. Yeah.
Per se.
Okay, hey, here's my question. Why does 71 make sense on this particular picture?
Because your
Because
math
it's
is bigger.
It's bigger than 25 and the wall is bigger.
Say it again.
The other angle's bigger.
Yeah, the other angle's bigger. Angle C is a bigger angle.
Makes sense.
When you have a larger angle in a triangle, the wall across from it better be larger.
You have a brain to turn on?
When the angle's smaller, the opposite wall is smaller. So that's why that made sense. B, that we're going to find later, better be very big. Better be larger compared to the 70 and 50. Now, it doesn't have to be like hundreds. It just has to be larger than the other two.
Let's
There's
try to figure it
limitations. There's limitations. Any two walls of a triangle have to be more than a third. So there are certain cases you have to double check, is it even a triangle? Because if we find B here, B has to be larger than 71.2. Has to be, it's the largest wall of the triangle. But it has to be smaller than these two added together, which is a 121.2. Because any two walls of the triangle have to add to be more than the third wall. So there is a limitation what that third wall is going to be. And if it turns out to be more or less, you can throw it out, it's not a triangle. Does that make sense?
Yeah.
Okay. Alright. Last problem. Okay guys, there's a lot of talking. And I guarantee you people don't know how to do this stuff, so you should not be talking right now. Okay, I want that problem that we had Friday. I need the numbers. I'm just going to put up the random triangle again. I don't care how it's drawn. I just need the numbers that I used on Friday. And I need to see the picture of it, because I need to put the numbers in the right spots. Otherwise, I'll just make it up. So, she wasn't here. Who was here Friday that has that example written down?
I think I missed that one example.
Number 35?
It was just a random problem that I had made up before the new class.
that one.
And I don't know.
Oh, wait, I wasn't here Friday either.
You have it? Okay.
One
This
example
problem
I didn't
potentially
take.
had two different solutions. Now, I'll just take it.
I'll just take it. Thanks for the
Well
handout.
done. Misplaced them, per se.
Well, here's that's the one example I put down on that one page of notes. I'll break it now.
We did a second one, but I don't know.
What number did she want? What
She had the
number?
ones with like 130, 30.
Yeah, I went with 30 and then 11.
Good observation.
11 and 10? That's one.
Like,
30, 11, and 10?
We already did that one though.
Syntax.
We did the first one, we didn't show that there was a second one to it.
Gary was there and he didn't have to. He took the time out of his day.
We even offered to re-bridge
Like that?
for him and then fix that.
We just didn't finish it. We did the first half.
Sure.
Okay. Alright, hey. Last problem of the day. You need to have this one written down if you did not, because it sounded like only select few people did have this one.
Oh, can we just do what we just did, do this problem?
Well,
Hypotenuse leg one.
we'll put
Hey.
sine of 30 over.
Guys, we're gonna stop talking. I'm not gonna stop correcting people today. I wanna get through this so we can get done today.
I think I know the answer.
Alright, this one, it's an inappropriate acronym if you actually look at the lettering of it. Just because of the setup, that when we put the A's and S's in there, it does spell the inappropriate ones. So, since we're at that last acronym here, this one has potential where it has two different sets of solutions. And I want to show you how and why that works. Since we have this, we can actually find this angle right here. That's really the only thing we can do as of this moment. Because of where the numbers are actually set, this angle could be wrong that we're about to find. Now the reason being is because this wall is like a pendulum. This angle isn't set, it's not like they told me this angle has to be 20. This is free floating. So really, this is not drawn to scale. So this wall could actually swing inwards, and if it could potentially connect like this, where this wall is still 10 here, and because it's going to make this circular path if it swings like an ice cream cone, because it's going to move inwards. And if it actually connects, this angle could be larger than what the number is on my calculator screen. So it does have potential to have two different answers. So that's what we're going to show, and how do you know whether it does or not? And I'm going to try to show you the math that's involved here. So the first setup is when I have it drawn, I try to assume that it has one answer. That's what I assume. And then once we're through it, we can see if there's a second one, and there's a little check that we do. Okay, so here's how it works. We're going to do the law of sine. So sine of 30 over its opposite wall, sine of angle, whatever that angle is up here, let's call it B, sine of angle B over its opposite wall. And I'm going to do the normal math, I'm going to do the little fish method that I always do. So you're going to start with the number above or below your variable, cross, multiply, and divide. You're going to get a decimal, because I'm taking 11 times the sine of 30, and I'm going to divide by 10, and it does give me a decimal on my calculator. And the reason why I know it's going to be a decimal is because whatever this is, when I cross multiply and divide, this is going to be equal to the sine of angle B. It's not whatever B is, it's sine of angle B.
Inverse sine.
And then, yeah, we'll have to take an inverse sine of it. Now, if I actually type this in my calculator, 11,
You'll get 33.36.
yeah, 11 times sine of 30, that answer is 5.5 here, divided by 10, you get 0.55, duh, I don't know why I typed that in, 0.55, and you get sine of B, and then I'll take the inverse sine to the other side, because if you need to find the angle, that's where you always use the inverse buttons on your calculator to find angles. So that if you don't know what that button is, it's doing this. Angle B is equal to the inverse sine of 0.55. And again, say the number.
33.36.
Okay, 33.36034. Let's just put one decimal place. Okay.
You could assume that.
So if that's my angle right here, so this is a 33.4. It makes sense. The angle was technically larger than the other one. The wall is a little bit bigger. Now, is that the only answer it could have been?
No.
No, because here's how you check. This is how you know if this is the only angle that it could be. Take 180. This is your little check you always do. To see if there's a second one.
That wall's
Take
not gonna be
180
bigger than-
and you subtract the number you just found. That's all you do. Take 180, subtract the number you just found. So 180 minus the 33.4. or
146.6.
So 146.6. Okay?
Subtract the
All right.
wall.
So you subtract. If this number, if you get this number right here, actually works with the 30 and it doesn't go over 180, because what do triangles have to add up to be? 180. So if it goes over 180, that's not a triangle. But if the 146 actually works with the other angle that's in the corner, so if we got a 146 here, 0.6, and this is 30, and this is 11, this is 10. So if that actually works, because what is that, a 176?
0.6.
So then this angle down here in the corner, if I take 180 minus 146.6 minus
How about
30,
3.4?
3.4 here, that could potentially be the second triangle you have.
That's
so
weird.
this wall will be incredibly small. Because it was the picture I was showing you earlier, that this wall could come inwards, so this wall is really short.
I have a question.
Yes.
Will you get on the projector and show us an example of like what that would actually look like drawn to scale?
Drawn to scale? Yeah, I could do that. Yeah, well, maybe I'll have that tomorrow when we do like more rigid types of questions, and I'll try to use this geometry sketchpad.
I want like the 3.4 degrees.
3.4, oh geez, it's really tiny.
I know, I want to see
Yeah.
it.
So,
Yeah.
we'll do it tomorrow. Because I'll try to put it on geometry
Probably
sketchpad so
won't
it'll do
work.
more
So I'm
accurate
confused.
drawings.
What if it's bigger than, if the triangle is bigger than 180? then
So
what's-
so if this, like, if you do the number here where you actually subtract, and it turns out to be more than 180, like when you put this number and this number together, you can't use that triangle, so you'd only have the one. So there's checks you can do. So this one has two potentials. What?
What shape does more than 180? Like what is it?
It's not a triangle. It wouldn't
It's
be.
fake.
I don't know what is it considered.
It's fake.
It would be considered what they call it. It has it's a convex type of picture. So because the angle would be actually.
I want to see a non.
It'd be probably wouldn't draw, right?
Yeah, it could possibly.
Okay, hey, questions? All right, now, today, you have the rest of the time today to work on your assignment. You're page 614. I had a request to do one of the problems. I'm going to do it on the board here.
16.
16 and maybe
And
35 or 36, something like that.
Let's just do
I'm going to do it on the
2, 4, 7,
board.
11, 16,
If you want to see it, you can come up there. If you just want to go work off in the corner. Just make sure you are staying quiet so those people that want to hear this problem can actually do it.
Blue.
Alright, and they just want you to solve it. They want you to find the exact answer without using a calculator, all that good stuff. Alright, this, if you first recognize this, this is a double angle formula. You can recognize it right away. It's 2 times sine of theta, cosine of beta, or whatever it is, or theta. Okay? So, if you recognize the formula, this thing is equal to sine of 2 times whatever theta is. That's the formula on your property sheet. So the theta that they're using is a 22.5. So this is sine of 2 times 22.5. Right, that's what they're doing. That's the same thing. Because that's my theta, right? So I'm going back to the original,
Right.
which 2 times 22.5 is sine of 45. and you just have to rattle off what the sine of 45 is according to your property sheet. So go to your unit circle, find 45, root 2 over 2.
Sure.
And that's it.
That's it?
That's it, done. You have the exact answer. You just had to recognize it was a double angle and you want to go back to the original answer.
That's all we have to
Okay.
put for the answer?
Yeah, this is the work I would expect to see, like that.
That's the same thing as
Final answer is gonna be
Okay,
root
alright.
2 over 2.
Okay, what was the other one, 36?
36.
So give me 36, what do you got?
10 cosine to the 4th. X.
10 cosine to the 4th, and then there's an x or something. Okay, you have to reduce this thing down. So you have to do the power reducing, simplify it so there's no powers, no parentheses. That's what they want. So cosine of cosine to the 4x. What that means is that you're doing cosine squared. That's what a power form is. So you're going to go in here and replace this with what the cosine double angle, or the power reducing formula is for cosine. So the power reducing one is in the upper corner. I think it's like,
It's 1/2.
yeah, it's
1 plus
1
cosine.
plus cosine 2 theta over 2.
It was so muddy.
Right, that's what it is. In that upper corner. It's 1/2, which is everything over 2. 1 plus cosine, correct? Yes, 1 plus cosine. Okay.
Wait, so what happened in the 1/2?
The half is there. It's just dividing it by 2. That's what happens. Okay. What you'll have to do is you're gonna have to write 2 of these parentheses out. Right? Multiply them together. Multiply them. So you're gonna have to write 2 parentheses, multiply them together, and you'll get something like this. And why you're gonna get a big 4 on the bottom because 2 times 2 on the bottom. The top you're gonna have to FOIL first, outer, and last. You get something like 2 cosine, 2 theta. You get a cosine squared theta. Right? What I would do next, distribute the 10 to everything on the top, so everything gets a 10.
10 plus 20
Yep.
cosine.
2 theta plus 10. Okay. Then divide each item. Take each item divided by 4. Just put a 4 on the bottom of each item separately. So the 10 over 4, the 10 cosine, or the 20 cosine, 2 theta over 4, and this 10 cosine squared theta over 4. Divide everything by 4. Then what I would do after you do that, replace this stupid thing with that again.
Can I take a picture of that on my
But you still have to hit B to read.
Yes, you better do it fast. And by the way, I already did this problem. I just wrote sine instead.
Okay, but
Lord, you are so clever, you know it?
so how do I even attempt to start that again?
So you're going to take that one out because they should be each individually separated.
I have 10 cosine squared theta over 4.
4. Put the 10 over 4 out front.
10.
10 over 4 out front.
And then you do that once.
And then you're taking this thing and plugging it in. This thing and plug it in there.
I say we just write the answer.
That's all you do. And then just distribute the 10 fourths. Because then you don't have any parentheses anymore. So, and that's where I'm going to stop there. I did that parentheses. You should look at the notes that I have for it.
Most that I leave here wrote.
Oh, you got shoved.